Alan.
Thank you. Thank you. It's so wonderful to see everybody. Thank you. Great to be here. And this morning I get to talk about the deadly blue skies of the ancient earth and your mom. So we are going to talk about that this morning. I did want to, before I get into that, I did want to mention that that a couple days ago, I was at the Native American boarding school memorial. I encourage anybody to go to that. Thank you. It's held every year right around June 6th. And just as a recap, it's important not to forget the actual history. The Native American boarding schools were when our U.S. government rounded up kids, took them from Native American families with the express purpose of eradicating the culture. These kids were subject to forced labor. Some of them died. Their culture was, of course, stolen. Language was banned. Some suffered sexual abuse, physical abuse. And the school for much of Michigan was right down the road here at Mount Pleasant. The school commemorates the closing of the school every year right around June 6th. The tribe owns the property now, sold to us by Governor Granholm for $1. People say, oh my gosh, there were up to 24 schools in the United States like this. No, there were 526 that we found so far. So this was a big, big deal. This is the one down the road. But that's not going to be the focus of my talk today. I did want to mention it. Today, I'm going to be talking about our history and one of the many ways that we're connected. Because the theme for this month is flourishing together, and this shows one of the many ways that we're all connected together. Now, sometimes when we're at a talk, someone will claim something, we're not sure if that's actually true, especially with all the misinformation today. I want to make it very clear to everyone today. This is my pledge that everything I present today is consistent with the scientific consensus, and if it's controversial at all, I'll say so. And best of all, you don't have to take my word for it, because down in the corner, a lot of these, I have the specific reference to the scientific papers that back this up. So with that, I will move forward. I want to point out that there's a lot of information here today. We only scratched the surface. This covers huge areas of geology, genetics, chemistry, and so much more. I'm making this so that we can all pull it in and not have to have every single detail behind us. I encourage anyone who wants to learn to look into it. It's really neat stuff. So with that, let's go back. Let's go back way, way back before, how about dinosaurs, right? Dinosaurs are pretty cool. Before dinosaurs, before Dimetrodon, before mammoths, before trilobites, we're going to go way back until the only things alive on Earth, well actually we'll go back all the way before there was any life on Earth. And back then, we had a very, very different planet. Here is what Earth looked like. This is what if somehow those courageous Artemis astronauts could look back in time and see the Earth, this is what they would have seen. Wow, look at all that green. This must be a lush planet of jungles and forests. No, nothing alive on land. What you're seeing is the ocean. Okay, green plants in the ocean? No. Back then, the oceans were green because they were filled with iron compounds. Iron, oxidized in its +2 state, is not as oxidized as it can be, and that solution is green. Iron chloride, things like that. The oceans were salty, but it was iron. And when you think about that, that's a lot of iron. We're used to iron compounds being red because they're more oxidized in the +3 state. So, if we look back then, the oceans are green. The sky is a seething, burning red, not from fire, but because of a lot of carbon dioxide, nitrogen, carbon monoxide, cyanide, methane, horrible stuff. Hydrogen sulfide, that's what smells like rotten eggs. They put it in natural gas so that you can smell it. Horrible, horrible stuff. Way more carbon dioxide than today because the plants had not captured it and buried it as fossil fuels yet. So that's the horrible, horrible Earth we had. What a nightmare. Who could live in this? That's the conditions that are needed for life to start. We need a reducing atmosphere, and that's what we have. Life started as small cells, and as these cells reproduced, they started to evolve and come up with new innovations in this world with no oxygen. What innovations did they have? They came up with, one more deadly thing. I forgot to mention, the sun is a deadly laser. Why? Because no ozone. We were all concerned a few years ago, those of us with gray hair like me, about the ozone layer being destroyed by chlorofluorocarbons. We did a great job banding together as human beings to fix the atmosphere. Can you imagine if we could do that again about something else? That would be great. We managed to help fix the situation. So, the only things alive are in the oceans. They evolved into many different kinds of cells, single-cell organisms, and some of them evolved the ability to eat other ones. The first predation. Predators back then eating single-celled organisms because that's all that was around. And some of them evolved the incredible ability to take this molecule, which is chlorophyll, and combine water and carbon dioxide to get energy and release oxygen. They started producing oxygen and things started to change. Now we're only 2.5 to 2 billion years ago. The oxygen content is going up in the atmosphere. And that is a deadly poison to everything that's alive. Almost everything. It's being killed by this oxygen. This horrible toxic pollutant is going into the atmosphere, but it's not building up very fast. Why not? Because remember, the oceans are packed with iron in a low oxidation state of +2, and that means that some of them are still alive today in Yellowstone. But that allows us to form iron in a +3 state, which is Fe2O3, which then doesn't dissolve in water. If it doesn't dissolve in water, what's it going to do? It's going to sink to the bottom of the ocean. Every little bit of iron that was further oxidized by this new oxygen sinks to the bottom as Fe2O3 and forms piles and piles and piles, hundreds of feet thick layers of Fe2O3, which we today call iron ore. Oxygen is being produced, it's being sucked out of the air by the iron in the oceans, and so for a long time, we still couldn't get much oxygen. We made so much of this Fe2O3 that years later, we would mine it and refine it and take the oxygen off and make iron for cars, for buildings, for all kinds of things, and load it upon ships like the Edmund Fitzgerald. That oxygen then built up in the atmosphere and changed the skies to a deadly shade of blue. Same with the oceans, no longer green, vibrant blue oceans below. And look at that. Now we have a blanket to protect us from the UV light with that ozone block. Now, and only now, life could leave the ocean and evolve onto land all around us. First thing to make it out, plants. Second thing, insects. Us vertebrate latecomers finally made it out around 375 million years ago. But let's stay back in that time. Way back then, we still had predation going on. We still had some single-celled organisms eating other single-celled organisms. And at one point, one of them ingested an organism and wasn't able to kill it and eat it. The organism survived. Survived as, what would you call that? A parasite? Mitochondria. So what's that of it? Awesome, yes. These managed to survive. And it had the special ability now that that little bacteria was able to take oxygen and not be killed by it, but instead metabolize that oxygen, combine it with fuel sources like glucose that we use in our blood, and produce energy. And that meant that these mitochondria became organelles in our cells. You could look at this and say, we've got these bacteria living in our cells. We do. They still live in our cells as the organelles, mitochondria. In fact, if you take the total amount of DNA in our cells, these bacteria still have their own DNA. That's one of the ways that it's so obvious that this happened, right? They've got a double membrane because they've had their own membrane and then they got encapsulated by our own cells. And they also still have their own DNA. And so if you look at the total amount of DNA in our cell and you like weight it or something like that, we have more DNA that's this kind of bacteria DNA than is in the nucleus, even though the nucleus itself has a much larger total amount when you look at like one copy, but you've got additional copies in your DNA in the mitochondria, copy and copy and copy of the bacteria DNA. So, what does this have to do with your mom? Let's find out. This person here figured it out. She looked at this and said, come on, you guys. You can see what happened here. Early cells, before they even formed multicellular organisms by clumping together to make multicellular organisms, even before that, had ingested these bacteria and made a symbiotic relationship that now forms these organelles in our cells, the mitochondria. She figured this out in the 70s and started to tell people and was mostly ignored because she's a woman. But she was courageous and persistent, and she kept it up until people finally had to listen to her and look at this and say, oh my gosh, she's just plain right. This is where we get our mitochondria from. She married some guy, too. Carl Sagan. I can't think of her name. Is Dr. Lynn Margulis. I met her at General Assembly one year. So, really, really neat. I was honored to meet her. So, yeah, I don't know of another couple where both people are so prominent. I mean, like the Curies, maybe the Curies come close. So anyway, she figured this out. She's the one who told the world. And today we can still find these kinds of organisms in stromatolites, which you can find in various places around the world. Here are some stromatolites. They're similar to algae. The chloroplasts are also symbiotic organisms that started out as bacteria. Chloroplasts in plant cells were also incorporated this way. And so our chloroplasts are in plant cells. Plant cells also have mitochondria because the symbiosis with the mitochondria happened first. So we don't have chloroplasts. But here's what the mitochondria look like. You can see they've got that folded surface to provide a lot of area for the chemical reactions we're talking about. And as I mentioned before, they have their own DNA. Of course they do. They're captured bacteria, right? Now, that means if they have their own DNA, that you can do a DNA test on them. And the amazing thing is what that tells you. What does it tell you? What it tells you is something that is a result of how this works. People say, oh yeah, I know how that works, right? Okay, the way this works is an egg cell is a big functioning cell. It's got all those organelles. It also has mitochondria. So we have mitochondria in there. And by the way, the word mitochondria is plural. And most cells have hundreds of mitochondria, at least dozens, depending on the size of the cell. However, the egg cell might have tons of these, but what about the sperm cell? It's a tiny little thing. It's just a little packet of DNA with a tail. It doesn't even have mitochondria in the head that ends up fusing with the egg. And that means that when this embryo forms, all the mitochondria are from the mom. And then it divides, and all the mitochondria in my entire body, in my fingers, in my legs, are all from my mom, none from my dad. As far as mitochondria are concerned, males are a dead end. Now, it may be true when you think about it, and the numbers are quite astounding. When you think about the numbers, you think you've got 2 parents, 4 grandparents, 8 great-grandparents, 16, 32, 64. It goes up so fast. If you go back just a relatively small, when you're talking about long spans of time, relatively small generations, we are descended from nearly everyone who was alive just a few thousand years ago. Nearly everyone. Because the numbers go up so fast. However, if you look at only the female line, then it's only 1 person in each generation. If you go back, if each of us went back even 1,000 years and said, who on the female line, moms, grandmothers, right? Are you descended from 1 person alive at each time? Because when you look at those and you look at this, you're only talking about the female line. So our mitochondria comes from just 1 line. Now, that line will have more mutations down the line that introduce changes to these mitochondria, so we can tell our mitochondria apart from the various people in this room. A lot of people were involved when I did a whole bunch of this stuff. Oh my, it was like 15 years ago, 10, 15 years ago. But I want to introduce you to someone. These are a couple of people scraping by without a lot of money in Detroit. Conversation with the older person in this photo, because she was in a state worse than Dan Seeley when I met her. But that's my great-grandmother, and that little girl is my grandmother. I carry their mitochondrial DNA. The mitochondria I got from these people powers my ability to stand here and tell you about mitochondria this morning. Because if you looked on a pure maternal line, then we can all trace back only 1 line. They eventually merge because of course you have the pedigree collapse that I mentioned before. And the mutations in here allow us to see those connections. They allow us to trace the migration of humans across the continents tens of thousands of years ago. Now, one could also do that with autosomal DNA, and one could also do that with Y chromosomal DNA, which are both not the subject of the talk this morning, and one could do that with archaeological evidence, and so on. And the amazing thing is that they all give us this same map. When we get confirmation like that from different ways of seeing things across the sciences, then we have a really good idea that this is really what happened. This is how humans got out of Africa to here and to the various continents. And of course, that's true of evolution as a whole. There are dozens of different lines of evidence, including mitochondrial DNA, that confirm the evolutionary family tree we saw this morning. So, how do we distinguish those different types of mitochondria? The way scientists do that is by grouping them in haplogroups, and mine is K2C1. People here have different ones. The surprising thing, how many people have heard of Otzi the Iceman? Some people have heard of Otzi. Otzi was discovered like, a good 25 years ago or more, as a frozen corpse sticking out of a glacier by a couple hikers, and they thought it was a murder victim. And then they started, the police came, and the police started to take him out, and they found this stuff. They found a bronze axe head. They found a quiver full of arrows. They found ancient leather boots, and they said, whoa, all right, we got to call university people. University people came, carbon dated him to 5,000 years ago. Okay, now hold on a second. Where did Otzi just popped up in this talk? Where is that? Why did Otzi pop up in this talk? I've got the same haplogroup as him. So, wow, some of the connections that show the different ways that we're all related. Dan Seeley gave us words of wisdom just a little bit ago when he mentioned all these people over there are my relatives. He was absolutely right. They're all our relatives. Everyone here are relatives. We're relatives with the trees out there if you go a little bit farther back. And that is another reminder of flourishing together. We're flourishing together because we're all family. So here's some of the main haplogroups that people have if you check them out. And I encourage you, if you haven't had a DNA test, you can find out what your mitochondrial haplogroup is. So it's also referenced in Star Wars. I don't know how many people remember the scene where young Anakin Skywalker, you remember, is Darth Vader, says, what are midichlorians? And Guy Quan Jinn, the Jedi Master, says midichlorians are a symbiotic organism that lives in our cells and gives us connection to the Force. He's right. They got the inspiration from mitochondria. So with that, I do want to have just a short diversion here that's not quite on the same subject. But I did want to mention it because it fits so well with flourishing together. With flourishing together, not just with everyone here, but with people all across the world. Because if we're going to tackle climate change, this is one thing you can do. And this is one, how many things can you do that really, really help? And you're paid to do, right? You're literally paid to do this. If you live in a house, EV is a great decision. The gas prices. People say, oh my gosh, gas prices are going up $4, $5, right? Yeah, sure they are, and that is horrible. If you have an EV, your gas price is $1.20 a gallon all the time. If you take that same $4, spend it on electricity instead of gas, that's how much you pay. And the reason for this is simple. The reason is that these gas cars that are driving around, they're not really cars. What's a car? What is a car? A car is something that's for driving. That's what it is. The main purpose to get you from one place to another. These gas cars are so inefficient that 80% of the gasoline energy is wasted as heat. Only 20% actually pushes the car. With an EV, 90% pushes the car. That means that what these things are, primary purpose, what 80% of the energy is used for? Heaters. We have a bunch of heaters, and they happen to move a little bit, and so we use these heaters as cars. That's what gas cars are. And so can you imagine, because what you do, you buy gas for $5 a gallon. What you're buying is $4 that you use as heat and throw out into the air, and only $1 pushes your car forward. That's how bad it is. EVs are so efficient. If you have a house, this works really well. You save money. It's not hard at all to hook up. I've done it. And so almost no maintenance, lots of other advantages, can provide power in a power outage, depending on the model and how you hook it up. But not hard at all to do. I know new things are hard. So if anyone has any questions, if they want to do this, Facebook me. I've already walked several people all through the process. How do I deal with this? What's this mean? How do I make this choice? I'll help you. I'll walk you through every step. And so will Jim Crispin sitting right here. So which either of us is less scary, feel free to reach out. We will help you out. So with that, I did want to mention that if you don't know how to contact me, ask around. Someone knows how to contact me. It's not hard. So with that, I wanted to open up just a few minutes for questions about how we can flourish together, knowing that we're all connected through our mitochondria.
I just wanted to say, electric cars are also really quiet, which I love.
Oh, I'm sorry, what?
Electric cars are really
That's right, they're silent. Oh my God. Oh yeah, we had to switch cars a little while ago to go on a vacation because I got a gas car. And Heather's like, what is wrong with your car? I said, what are you talking about? She says, it is so sluggish and loud. I said, gas car. Yeah.
What does mitochondria do for us besides tell us who our ancestors
Oh,
are?
that's a great question. Mitochondria metabolize oxygen. Because they can metabolize oxygen, they provide all the energy we use to move, to think, to digest, to do anything. All that power comes from the mitochondria burning glucose with oxygen and producing carbon dioxide. We obviously could not live without mitochondria, same with almost all life on Earth. Yeah.
I did not understand why the blue skies are deadly. How are they deadly? Is that what the deadly blue skies of the ancient earth have to do with it?
Hold on just a second. Can someone repeat that for me?
Why blue skies are deadly?
Oh, yeah. That's a great question. Because back then, the blue sky showed the presence of oxygen, and almost all the life on Earth back then couldn't survive in an oxygen atmosphere. And so it killed off a lot of the life back then at this first great extinction. And we and everything alive today are the descendants of the things that could survive that cataclysm. All right. Yeah, Monica.
What do you tell people who don't believe in evolution?
You know, that's a great question. That's a great question because there's a lot of people like that, and it comes up from time to time, and it really depends on the circumstance. If they're open to listen, right, if they're open to learn, then I ask them, what questions do you have? They often have a lot of really, really good questions. If they're not open to learn and they're just advertising creationism, which, by the way, I realized this short phrase a little while ago, and it's a little bit scary, and that's that if you are promoting something that isn't factually true, like creationism, if you are promoting anything anti-vax, anything that's not factually true in the real world, then you are a predator or a dupe or both. A lot of people are both. And if that's the case, then I talk to them in ways that make sure that everyone else listening, if it's the case that they're not going to listen no matter what I say, right? There's a lot like that. If that's the case, I talk to them and usually still try to be nice, but in ways that anyone listening can benefit from, because other people can be listening a lot of times, like on Facebook or something like that. If I'm alone with them and no one else is listening and there's no way I'm going to change their mind, then there really isn't much to say. I wish them a nice day and keep from wasting my time. So that's the short answer. Yeah.
Could you cover the role of nitrogen in this evolution of life?
I would love to cover the role of nitrogen in the evolution of life. That would be a whole nother talk, but just in the very short time we have for that, nitrogen, bacteria evolved that could metabolize nitrogen, and that was really, really important to get it into the cycle. We have a nitrogen cycle, and certain bacteria formed a symbiotic relationship that are present in the roots of plants, specifically beans, that can get the nitrogen out of the air, because N2 that's in the air is very, very stable. It's very difficult to get that in a form that we use. And we really need it for all kinds of stuff in our metabolism. So that has a whole process of bacterial mutations leading to symbiosis, just like oxygen. Don't want to run over too much on time. How are we doing?
We're at 5 minutes.
Oh, I see it. Yep. Yeah, we're a little over, so we'll move on. Thank you, everyone.